Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about carbonyl compounds lecture 2. So this will be highly beneficial for BSc chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus under CC6 paper semester 3 unit 3. So today we are going to talk about nucleophilic addition reactions, nucleophilic addition elimination reaction with ammonia derivatives with mechanism. So this is the prerequisite knowledge that everyone must have. So usually the reactant is converted to product in the presence of reagent. So how that reactant is converted to the product with the help of reagents, that is known as mechanism. So what mechanism shows? It shows the mechanism, the movement of double-headed arrow, how bonds are broken and new bonds are formed, leading to formation of product, which may be multi-step process or one-step process. Usually when a bond is broken heterolytically, on which atom the bond is broken, that gets both the electrons with negative charge, so that we call as nucleophile. Similarly, other atom becomes electronically deficient, so A plus, electrophile. And usually the nucleophile always attack the electrophile, giving rise to nucleophile-electrophile bond. And when the bond is broken, then you generate the nucleophile and electrophile. So today we'll talk about nucleophilic addition reactions. So usually the nucleophile will attack this carbonyl carbon because this bond is polarized. So oxygen has a delta negative charge and carbon has delta positive charge. And this CO double bond will break on oxygen. So as a result you get this tetrahedral intermediate. So once you get this, O minus will take the proton from solvent, giving rise to the nucleophilic addition product. So first reaction is addition reaction with sodium bisulfite. So this acetone react with NaHSO3, giving rise to acetone bisulfite. So Na plus and SO3H minus. So this act as nucleophile. So it will attack this carbonyl carbon and this CO double bond will break on oxygen. As a result, you end up with this product, and again proton transfer will take place internally, giving rise to acetone bisulfite. Similarly, carbonyl compound can undergo addition reaction with hydrogen cyanide, HCN. So giving rise to cyanohydrin. So HCN is an ionic compound. So this simply ionizes to give H plus and Cn minus ion. So Cn minus ion act as nucleophile. It will attack this carbonyl carbon and C double bond O will break on oxygen. So once you get this tetrahedral intermediate, O minus will take the proton from HCN, giving rise to this cyanohydrin. The next is addition with Grignard reagent. So Grignard reagent is R minus MgX plus. So this R minus will attack as nucleophile and C double bond O will break on oxygen. So you get O minus MgX plus. So you get this tetrahedral intermediate and this O minus will take the proton from water, giving rise to OH minus ion, so that becomes MgOHX and alcohol. So next is nucleophilic addition elimination reactions with ammonia derivatives with mechanism. So we know the ammonia formula is NH3, so that we can write as H hyphen NH2. Similarly, if we replace this hydrogen with another group, so ammonia derivative we will get. So we write in general G hyphen or G hyphen NH2 as ammonia derivative. So when instead of hydrogen, if we take the OH group, so that becomes OH NH2. This is known as hydroxylamine. It would react with carbonyl compound, giving rise to oxime. Similarly, when G is NH2, so this is NH2 hyphen NH2 hydrazine, and it would give hydrazone. When G is C6H5 hyphen NH, so this is phenyl hydrazine, C6H5 NH hyphen NH2. It would react with carbonyl compound, giving rise to phenyl hydrazones. So when G is NH2 CONH, so this is NH2CONH so semi-carbazide, and it would react with carbonyl compound giving rise to semi-carbazones. When G is this one, so this becomes a 2,4-DNP, 2,4-dinitrophenyl hydrazine, and this would react with carbonyl compound giving rise to 2,4-dinitrophenyl hydrazones. So now let's talk about in general the reaction mechanism. So this is the carbonyl compound and this is the ammonia derivative NH2-G, and you will get this product. So this is the addition elimination product. So first step, the addition of nucleophile. So this ammonia derivative, nitrogen has lone pair of electrons, so it will attack as nucleophile. It will attack this carbonyl carbon of carbonyl compound, and C double bond O will break on oxygen. So as a result, you get this protonated species, and again this O minus will take this proton and this NH bond will break on N plus. So you get this hydroxy product. So in second step, elimination lead to C double bond N in the final product. So this oxygen lone pair will attack to the H plus, so it becomes OH2 plus. So again in this step, elimination of water molecule lead to the double bond, C double bond N. So this NH bond will break on here and this CO bond will break on O plus, giving rise to final nucleophilic addition elimination product. So here is the problems for you guys, nucleophilic addition elimination reaction. So if you react with hydroxylamine, you get oxygen. If you react with hydrazine, you get hydrazones. If you react with phenyl hydrazine, you get hydrazone. So you have to write down all the mechanisms for these three reactions. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website chemistryliveugpg.com. So this is the YouTube channel Foundation Chemistry AB for 11th and 12th class students. This is also available in the website www.foundationchemistryab.com. This is a simple step towards e-learning making life better. Thank you all for learning.